The next part of this unit, we are going to be looking at solving systems of equations. So solutions to systems of equations can be found using algebraic methods, not just graphing. Graphing is not always going to be the most convenient. So first method we're going to use is substitution. Eventually we're going to get some other methods and you'll be able to choose what you like best, but right now we're going to practice just using substitution. When you think of the word substitute, it means you're putting in place of, or you're substituting in, right? If you have a substitute teacher, they're taking place of the teacher. Same thing applies here. We're gonna pick one of the equations. Maybe it's already solved for x and y, or you're going to solve them for x or y, and then you're gonna plug this into the other equation by substituting it in for that chosen variable. So first thing I should look for is, do I have an equation that is already y equals or x equals? We do in this one, y equals 3x. So that's what I'm going to substitute in. I'm going to take what y is equal to and plug it in where y is in the other equation, so that equation can be all x's. Because if there's two variables right now, we can't solve it. We need to make it all just x. So I'm plugging in x plus 2 times our y value, which is equivalent to 3x. So that's the same thing as y, equals negative 21. So we get x plus 6x equals negative 21. So 7x equals negative 21, which means when I divide by 7, that x is equal to negative 3. When we are solving the systems of equations, we don't want just the x value. We want the ordered pair of the x and the y. So now what I'm going to do is I'm going to take this x value and plug it back in. I technically can plug it into either equation, but there's generally going to be an easier one to plug it into. The one that's already in the form y equals is going to be the easiest to plug into. So if I plug that back in, y is equal to 3x's. So it's equal to 3 times our x value that we solve for of negative 3. So 3 times negative 3 is negative 9. Now, when I write my answer, I'm writing it in the form of an ordered pair. So our x value of negative 3, comma, our y value of negative 9. I could have plugged the negative 3 into here, and we would have gotten the same answer. Okay. All right, number 2. First thing I'm looking for is, do I have a y equals or x equals equation? Yes, I do, right here. So I'm going to take my value of what y is equal to and plug it in for y. So y equals 5x, so we're going to plug in 5x where y is. So 2x plus 3 times our y value of 5x is equal to 34. So 2x plus 15x is equal to 34. 17x is equal to 34, which means that x is equal to 2. So we're going to take that x value and we're going to plug it back in. The easier equation is going to be the one that's already in the y equals form. So y equals 5 times the x value that we just solved for, 2. So y equals 10. So in our ordered pair form, our x value is 2, comma, our y value is 10. Next up, for number 3, we do not have an equation that's in the form y equals or x equals. So essentially, I need to solve one of these equations for y or x. So the next thing I look for is, do we have an x or a y that has a coefficient of 1 or negative 1? And we have that right here. So I'm going to solve this equation for y by subtracting 5y from each side. So that would make this equation x equals negative 5y minus 3, or x equals negative 3 minus 5y. Now I can use that to substitute in. What we are going to substitute in is this entire value where x is. And being careful to use parentheses because it needs to apply to this whole entire thing. So I'm doing 3 times the x value, and I'm putting in parentheses, which is negative 5y minus 3, and then bring down our minus 2y equals 8. So let's simplify. 3 times negative 5y is negative 15y, and 3 times negative 3 is negative 9. Bring down our minus 2y, bring down our equals, bring down our 8. I'm going to simplify first. We have negative 15y and negative 2y, which is negative 17y, minus 9 equals 8. Next thing I'm solving, if I'm subtracting 9, I'm going to add 9 to both sides. So I get 17y equals 17, and I divide those both by 17, so I get that y equals 1. Now we're gonna go back and we're gonna plug in this y value of 1 into any of these equations. I can do this first equation, I can do the second equation, I can also technically do this equation as long as I did that correctly. It is up to you. So if I plug it back in here, I have x equals negative 5 times a y value of 1 minus 3. So I'm going to write down here x equals negative 5 times 1 is negative 5 minus 3, and negative 5 minus 3 is negative 8. So our ordered pair, x comes first, negative 8, y comes second, 1. So our solution is negative 8, positive 1. All right, number 4. When we're looking at this, we actually have 2 equations that are in the form y equals. So essentially what's going to happen is I'm going to plug in this 2x where y is. So it's going to replace that whole entire value. So y is equal to both of these. So this whole thing is being plugged in where y is. So 2x plus 3 is on the left side of that equal sign. On the right side, we're going to write the same thing, 4x minus 1. Now we have an equation with variables on both sides that we need to solve. I'm going to move my 2x to the right. I get 3 equals 2x minus 1. I'm going to move my minus 1 to the left. So we get 4 equals 2x, which means that x equals 2. Now we're going to plug that back in to either equation. It does not matter. Maybe we go to this one because it has the positive values. So y is equal to 2 times an x value of 2 plus 3. 2 times 2 is 4, plus 3, y is equal to 7. So our ordered pair, x comes first, which is 2. Y comes second, which is 7. So our ordered pair is 2, 7. All right, one more, and then we're going to look at some special cases. So, number 5, 2x plus 3y equals 1, and negative 3x plus y equals 15. So neither one of these has an equation that is y equals or x equals. But I do see that this equation has a y value that has a coefficient of 1. So that's where I'm going to start. I'm going to solve this for y by getting rid of this negative 3x by adding 3x to both sides. So my new equation is going to be y equals 3x plus 15. So we're going to use this, and we are going to plug in this whole entire y value in where y is. So 2x plus 3 times our y value, which is equal to 3x plus 15 equals 1. We need to distribute. Positive 3 times positive 3 is positive 9x. Positive 3 times positive 15 is positive 45. Bring down our 2x, bring down our equals, bring down our 1. Next thing I'm simplifying, 2x and 9x makes 11x plus 45 equals 1. Get rid of 45 by subtracting from both sides, and we get 11x equals negative 44. When we divide that by 11, we get x equals negative 4. Now we're going to take this value of x and plug it back into either equation. So I can plug it into the top equation, I can plug it into the bottom, I can plug it into the one that I reworked, as long as I reworked it correctly. Let's say I plug it into the second equation here. So we're going to do negative 3 times our x value of negative 4 plus y equals 15. Negative 3 times negative 4 is positive 12 plus y equals 15. Subtract 12 from both sides, and we get y equals 3. So our ordered pair, x comes first, negative 4, y comes second, 3. That is our solution, negative 4, 3. All right, last thing that we're going to look at is special case scenarios. So sometimes we don't get just one solution. We talked about that with graphing, right? You could have one solution, you could have no solution, you could have all solutions. So that's what we're going to look at here. So when I solve this, we have y equals 3x plus 2. So here is where we have just y equals. I'm going to plug in this value for y in the first equation. So we have 6x minus 2 times our y value, which is 3x plus 2, equals negative 4. When I'm distributing, I got to be careful. We have a negative 2 times a positive 3x is negative 6x, and a negative 2 times a positive 2 is negative 4. So we get 6x minus 4 equals negative 4. When I simplify here, 6x minus 6x is just 0. They cancel each other out. And we are left with negative 4 equals negative 4. Okay, we have no variables left. What does x equal? What does y equal? What I need to ask myself is, does this make sense? Is negative 4 equal to negative 4? Yes, this is a true statement. If that is a true statement, it means all solutions work. I can plug in multiple values for that, and every single value, it is going to work. Next scenario, you might already be guessing what that one is, but I want to show why it is that way. We have a y equals equation. Y equals 3/5 x. So we're going to plug in 3/5 x where y is. So we have 3x minus 5 times our y value of 3/5 x is equal to 15. So to simplify, we're doing negative 5 over 1 times 3 over 5. So 5's cancel to 1, and we get 3x minus 3x equals 15. When I subtract here, 3x minus 3x, that is just 0. They cancel each other out. So does this make sense? Does 0 equal 15? No, this is false. So what that means is it's no solution. It does not work. There's no intersection point of those two lines. And that's it.